All right, welcome. Today we are going to unpack a super powerful mental toolkit, one that can seriously help you understand, well, almost anything. Okay, so code, circuits, and even your own ability to focus. What in the world do they all have in common? It kind of sounds like a riddle, right? But trust me, the answer reveals this amazing universal way to solve problems. We're going to connect these worlds that seem totally separate and see how the exact same logic can unlock every single one of them. I mean, just think about it for a second. We live in a world that's just full of these complex black boxes. From the apps on your phone to the tech in your car, even your own habits. We're just surrounded by these super intricate systems that, for the most part, just work. We use them every single day. But do we really know how they work? Not really. But what if you had like a universal key to unlock all of them? Well, that's exactly what we're going to talk about. We are building an engineer's toolkit for, well, everything. It's a way of thinking that lets you deconstruct any problem. Doesn't matter if it's made of silicon, software, or get this, even human psychology. All right, section 1, deconstructing the digital world. Let's turn those abstract code ideas into something concrete. So, first up, let's dive into probably the most common black box we all deal with, the digital world. How on earth do engineers look at a massive, super complex piece of software and actually make sense of it? Simple. They start by breaking it down. Okay, let's take a concept like automation. It sounds simple enough, but an engineer, they immediately start breaking it into pieces. So on one side, you've got what you could call a clicking robot. That's RPA. It just follows a really strict script, doing the same thing over and over. But on the other side, you have the thinking system, APA. This thing actually uses AI to analyze, learn, and make its own decisions. See? Just by defining these two different types, that big, scary black box of automation suddenly starts to open up. And this same way of thinking applies to the actual building blocks of software. See, an engineer doesn't just look at a screen and see code. No way. They see the individual components. Think of it like this. An API, that's the messenger, letting different programs talk to each other. A library, that's your toolbox, full of pre-made tools so you don't have to build everything from scratch. And a framework, that's the blueprint for the whole shebang. Understanding these separate parts, that's the absolute key. So the pattern here is becoming super clear, right? You break the big problem down into smaller, much more understandable parts. And that right there is the very first tool for our toolkit, deconstruction. It doesn't matter if it's software or some complicated process, the first step is always to break that big, intimidating problem into little pieces you can actually wrap your head around. Okay, now for part 2, from code to circuits. We're going to see how we can apply this digital logic to the physical world. So now we're going to take this exact same way of thinking from the abstract world of code and apply it to the very real physical world of electronics. And I think you're going to be surprised at just how similar the approach actually is. Yeah, I mean, if you're not an engineer, a circuit board can look like absolute magic, right? A total mess of wires and components. But to an engineer, it's just another system. It might be a physical black box, sure, but it's one that follows a very strict set of rules. Just like a software algorithm. And this is a perfect illustration of the method. So how do you understand an amplifier circuit? Well, step 1, you identify all the little components and what they do. Step 2, you apply the fundamental rules, things like Kirchhoff's laws, the basic physics. Step 3, you figure out an expression for the output. And finally, step 4, you define its limits, what it can and can't do. See? It's the same pattern. It's a logical step-by-step deconstruction, but this time for a physical thing. And this goes way beyond just circuits. From software algorithms to the laws of mechanics, the approach is always the same. Find the first principles. The core engineering mindset is always about stripping away all the complexity to find those fundamental, unbreakable rules that are really running the show. All right, section 3, the ultimate system, you. Let's talk about how to engineer your own productivity. Okay, this is where things get really, really interesting and personal. We've broken down code, we've broken down circuits. So now let's turn that awesome engineering toolkit inward and use it to manage the most complex system there is, ourselves. So how do you actually engineer a productive day? Well, you start by defining the core systems that are at play. On one hand, you've got velocity. That's your drive to complete tasks, to move forward, to hit your goals. And it burns energy. Then, on the other hand, you have preservation. This is your need to conserve that mental energy, to rest, to recharge. It restores your energy. Your entire day is just a constant balancing act between these two competing forces. And this quote just hits the nail on the head. Consider the modern workday as a logistical problem involving a finite energy source, the human brain, and a fixed timeline. It says it all, right? You are not a machine with infinite power. You're a system with a finite energy source, your brain, and only so many hours in the day. Thinking this way completely changes the game. Productivity isn't about willpower anymore. It becomes a problem of resource management, a logistics problem. So if your workday is a system, then what's burnout? It's a system failure. And what do engineers do when things fail? They create procedures. So here's a procedure for clearing mental fatigue. This isn't just, take a break. It's a real algorithm. First, you acknowledge the fatigue, no judgment. Second, you disconnect completely for a bit, maybe a 30-minute nap. Third, you come back and re-engage with a super simple low-effort task. And fourth, you gradually ramp back up to the harder stuff. It's a repeatable, engineered solution for your own mind. Okay, our final section, your universal toolkit. Let's look at the mental models for deconstructing anything. So after this whole journey, from code to circuits to our own minds, what have we actually put together? Well, we've assembled a really powerful set of mental models, a truly universal toolkit for understanding just about anything. So here they are, the engineer's mental models. This is your toolkit. First, break down complexity. You have to isolate the smallest moving parts of any system. Next, define the components. Really understand what each part is and what its job is. Then you have to identify first principles. Find those fundamental rules that the whole system has to follow. After that, you systematize solutions. Create repeatable processes for problems that keep popping up. And finally, you optimize for efficiency. Always be trying to balance what you put in with what you get out to get the best possible result. But here's the most important part of all of this. This isn't just for engineers. You absolutely do not need an engineering degree to use this toolkit. It's really a framework for being curious. It's a method for anyone who wants to go deeper than just the surface level and truly deeply understand how things work, whether it's your laptop or your own life. So I'll leave you with this question. Maybe it's a new skill, a complex project at work, or hey, even a personal habit you want to change. What's the first black box in your life that you're going to open up with your new toolkit? Thanks for watching.